Okay, we're going to go through an example that shows you how to debounce your signal. And first off, I'll show you why you might want to do that. The issue is whenever you have a mechanical button or mechanical switch, the signal as it transitions from on to off or off to on, it's not a perfect transition. It'll in the real world, it transitions from on to off rapidly, usually a couple times as it's making its transition. It's very, very quickly done, but our PLCs in a typical application will run around 5,000 scans per second. So they run fast enough that they will frequently catch these very rapid transitions. So you want to sometimes slow down the process a little bit for particular inputs. You wouldn't want to do this for all your bits, but just your input bits may sometimes require this to kind of filter out those mechanical bounces. So I'll show you an example here. I've just got an ACE 11 and I've got a simulator stick plugged in, and that's what I'm going to use to make my transitions. And all this program right now does is go from the start to a count, and I've got a variable I created, a tag created, total count, and it counts up every time my input bit rises. So I'll program it, I'll run it, and maybe I need to program it. Okay, run it and go into debug mode, and we'll check out the value. And you'll be able to hear me clicking, but what I'm going to do is I'm going to click it to the on position and then back to the off position. So every 2 clicks it should go up 1, but you'll actually see it go up more than 1. Because of this mechanical debounce. Not all the time, but sometimes. So you see frequently it was counting twice as I was turning into the on position. And in this case I'm not seeing it count as it go into the off position, but sometimes you would. Okay, so you see the problem, and now we're going to show you a solution to this. So I've got a subroutine I've created. I'll show you what's in that. We've got an input bit, and this is where I'm going to put my actual input signal. And it's just passed by value into my subroutine. And then I've got another one that I'm calling debounce, and that's what is going to be the filtered signal. Okay, and the routine's pretty simple. This is the whole thing. You start off a timer. And then in my case, I'm wanting to send a signal every. I'm wanting to record the value every 50 milliseconds. So whenever my timer is greater than or equal to 50 milliseconds, it goes into this path. And if it's not, it goes ahead and returns to the main subroutine, which will cause it to be called again very, very soon. But every 50 milliseconds, it does some stuff. And you see it's part of this copy here. I put a 0 into my timer, which is the same thing as resetting the timer. So it's going to cause this thing to happen again, next 50 milliseconds. But what's happening here is I'm taking the input bit that we're passing in, and I'm copying it to UI8. And the reason I'm doing that is we're going to use some math. We're going to use a calculator block, and calculator block works with all the data types except for bits. So I wanted to put it into UI8, and then I'm going to copy the previous val 1. I'm going to copy that into val 2, and then the time before that's val 1. It's going to go into val 3. So we're going to get 4 samples. So this is going to take us. We're basically checking has the value been what's the value been over the last 200 milliseconds, and we sampled it 4 different times in that 200 milliseconds. And then we go into this calculator function here, and we add all those up. And basically, I'm wanting to see have the values been the same thing for the last 200 milliseconds. If so, I feel like we've got a steady signal and we can run with it. So we add them together, and then I ask, is the total 4? Basically, are they all on? If so, I'm going to turn my output on. If not, I ask, are they all off? If so, then I'm going to turn it off. And if they aren't all on or all off, then I'm just returning, and it's going to leave the former value in place. So it's not going to transition that bit at all. Just debounce will be whatever it was the last scan. So I've got my main routine here, and I've actually got a little subroutine call I stuck down here, and we'll pull this into our project, and I will have a loop around. So now it's going to do a subroutine call, and you see I'm passing the input bit C1 just like I was using here. I'm passing that into my subroutine into input, and then I've created a local bit here also called debounce. We're passing that by reference, so the subroutine will update the value of that for us. And then I need to make one change here. Instead of every time C1 rises, now we're going to use that debounce tag. And we'll go ahead and run this, and I'll turn it into debug, and we'll look at the bit, and we'll do the same experiment. So 1, 2, 3, 4, and we'll do it one more time, 5. You see it counts exactly how many times we intended to, because we're checking it for consistency over a 200 millisecond period. Your exact application, you may adjust those times a bit, but this is an example that should get you going.